All right, so one more way to describe how spread out data are is with the coefficient of variation, or in other words, CV value. So this is the standard deviation divided by the mean expressed as a percentage. So the two formulas for the CV. Well, if you took a sample of data values, you could find the sample CV. You would take the standard deviation of the sample, divide by the sample mean, multiply by 100%. Now, if you had all the data for your population, you could find the population CV. You could find take the standard population standard deviation, divide by the population mean, mu, multiply by 100%. And I say the CV allows us to compare how spread out one set of data is compared to another. So again, as with everything else in this class, this makes a whole lot more sense once you actually work an example. So, all right. So, suppose a sample of men yields a mean height of 68.34 inches with a standard deviation of 3.02 inches and a mean weight of 172.55 pounds with a sample standard deviation of 26.33 pounds. Do men's heights or weights appear to have more variation? Or in other words, are men's heights more spread out, or are men's weights? Okay, now if you think about it, if you walk around in public and you look at men's weights, well, if you just look around, you'll see men of all shapes. So it's not that weird to see a man who's 150 pounds. It's not that weird to see a man who's 250 pounds or 300 pounds. So men's weights, they're all over the place. They're very spread out. Now men's heights, though, if you look around in public, typical man is about 5'9" maybe. It's pretty rare to see a man who's 6'3", 6'4", and it's much rarer to see a man who's say 6'7", 6'8", or 7 feet tall. So men's heights are less spread out than men's weights. At least our intuition tells us that. So what we want to do is crunch some numbers that that explain this to somebody. Okay, but here's the problem. In general, a higher standard deviation means more spread out. So if the standard deviation for women's heights was like 10 inches or something, that would mean women's heights are more spread out than men's heights because men's standard deviation is smaller. Okay, but what we can't do is just say, oh, 3 inches is less than 26 pounds, therefore men's weights are more spread out. That doesn't make any sense. You're comparing apples and oranges there. You can't compare inches to pounds. So, if you think about it, I mean, we have different units here. If you were to convert these numbers from inches to millimeters and you said, okay, the mean height of men is 1,735 millimeters, and the standard deviation of men's heights is 76.7 millimeters. That would be telling you the same information. So all of a sudden, if you just switched from 3 inches to 76 millimeters, all of a sudden your standard deviation seems like it's going up. I mean, it's a bigger number. But that doesn't change how spread out things are. So the point is, you can't compare a standard deviation in inches to a standard deviation in pounds. It doesn't really make much sense. So you can't compare these numbers directly. So, but we can use the CV value. So for heights, okay, what's the CV for sample CV for men's heights? Well, we got to take our S, our 3.02, we got to divide by 68.34, multiply by 100%. And that gives us 4.42%. All right, then we'll do the same thing with men's weights. So, CV, you got to do sample standard deviation, 26.33 pounds. got to divide by the mean, which is 172.55 pounds. Multiply by 100% to convert to a percentage, and you get 15.26%. Now, what did we just figure out? Well, what the CV is telling us right here is that most men's heights are within about 4.42% of the mean. The CV over here is telling us that most men have weights that are within about 15.26% of the mean. Well, what this is saying is that men's weights are therefore, in general, more spread out than men's heights. Men's weights are usually within about 15% of the mean, and men's heights are usually within 4% of the mean. Well, that's telling you that the data over here is closer together comparatively to the data over here. So because this number is less than this number, men's heights are less spread out. Or in other words, men's weights are more spread out. So men's weights are more spread out. Or in other words, there is more variation in men's weights. Okay. New problem. All right. Suppose that you somehow know that for men's heights, we have that the population mean, or the average height of all men, is 68 inches, and the standard deviation, population standard deviation for all men's heights is 3 inches. So suppose you somehow knew that. So suppose somebody grabbed every man in the world, found the average height, found the exact standard deviation of all men's heights. My question is this: about what percent of men are shorter than 62 inches? And I say, to answer this question, what assumption are we going to make? Well, we will assume men's heights are normally distributed. So we talked about that before. It makes sense that men's heights would follow a bell-shaped curve. So we will assume men's heights are normally distributed. Well, why is that helpful? Well, look at the top of the page. So, if a population has a normal distribution, 68% of the data will lie within 1 standard deviation of the mean. 95% will lie within 2 standard deviations of the mean. All right, well, so let's draw our curve here. So, average height of men, 68 inches. We'll put that right in the middle. Mean height of men. All right, now if we move out 3 inches, so we go over here to 71 inches, we go down here to 65 inches, we find that 68% of the data are between 65 and 71 inches. If we move out 2 standard deviations, so we go out here to 74 inches, we go out here to 62 inches. Well, we know that 95% of data are between 62 and 74 inches. Or in other words, 95% of men have heights between 62 and 74 inches. Now, wait a minute. This question is asking what percent of men are shorter than 62 inches. So in other words, what percent of men lie over here? Well, this curve, when we look at this curve, it's describing all men in the world, or 100% of men. If 95% of men are in the middle, 5% of men are left over here and over here. Well, if we look at this curve, this tail looks just like this tail, this data symmetric. So what that must mean is that 2.5% of data are over here, and 2.5% of data are over here. So if 5% of men lie outside this interval, then you got to have 2.5% over here and 2.5% over here. Aha! So if we ask what percent of men are shorter than 62 inches, so what percent of men have heights to the left here? It's 2.5% of men.